Hey folks, I want to let you know about the sponsor of today's episode, Stream. Stream powers chat messaging activity feeds for billions of global end users across thousands of different apps. So if you want to do anything with chat or feeds, then you definitely want to take a look at Stream and their awesome SDK. They have SDKs not only for iOS, but Android as well as React, Unreal, Angular, Unity, Flutter, and more. They obsess over their API and its ease of use for its customers and provide awesome tutorials for their developer teams. So if you're looking at adding any sort of messaging to your app, Stream and Stream Chat is going to be the easiest way to do it in your iOS app. They provide all sorts of high-level UI components to connect Stream Chat API with minimal coding. If you're on iOS, they have both SDKs and Swift packages available for UIKit as well as SwiftUI. Go ahead and click on the link in the show notes below to try Stream Chat for free for 30 days, or apply for your Maker account, free forever, or qualifying teams. If you're looking at adding any sort of messaging or activity feeds to your app, then Stream is definitely the way you're going to want to go. Accelerate your launch, focus on your app rather than having to worry about all sorts of problems with networking and messaging and social feeds, and grow your app. Stream is trusted by thousands of companies, more than 1 billion end users to reliably scale regardless of demand. Go ahead and click on the link in the show notes below to give Stream a try today. Thank you, Stream, for sponsoring today's episode. Welcome to another episode of Empower Apps. I'm your host, Leo Dion. Today, I am joined with Zev Eisenberg. Zev, thank you so much for coming on. I really appreciate it.
Thanks. Pleasure to be here.
Before we begin, I'll let you introduce yourself and what you do.
Sure. Hello, I'm Zev Eisenberg. The very short version is that I was raised by clowns, but I ran away to join the circuits. I work at the New York Times. I worked on the Kids app, or I worked on the news app for a little while, and now I work on the new Kids app that we're putting together. It's in sort of early testing right now.
Is there a test flight invite for it?
So it's actually in the App Store, but you need to be on the special invite list.
Gotcha. Okay. Very cool. That sounds like awesome. What's just kind of curious your experience building that Kids app. What are some things that you've kind of learned in the design and building of it at New York Times?
Yeah, it's been nice to work on something greenfield, new code base without a lot of legacy stuff. Because coming from the news app, it's a big established code base, and it's sometimes hard to even track down. Where's the thing? Where's the person I need to find to do the thing I'm trying to do? I mean, that's nothing special about that code base. It's any big company with an app more than a couple of years old.
Right.
But it's definitely been nice to start greenfield. One of the interesting challenges has been that we have a whole bunch of kids privacy regulations and laws that we need to follow that the other apps at the company aren't really beholden to.
Makes sense.
That meant that we needed to build a bunch of stuff from scratch that any other team at the company would just be able to use our existing publishing infrastructure. So it's been interesting, mostly on the backend side, just seeing what that ends up looking like, having to build our own CMS. Right. On the app side, we ended up using SwiftUI and the Composable Architecture, which are both fairly new to the company as well. So nice opportunity to play with some new stuff.
Nice. So let's get into that. What exactly is composable architecture? Because I've heard of the term before, and I know the folks. Gosh, I can't remember the name.
Point Free. It's Brandon and Steven.
Yes, from Steven and Brandon. Yeah.
Point Free.
I've heard of it referenced a lot. Why is it so important? Why is it so great?
So first of all, just on architecture in general, I feel like a lot of what's the expression? A lot of ink gets spilled about architecture on iOS, and I think that's partly because on Apple's side, they're both very opinionated. They say you should use MVC. At least that was the case for UIKit. In SwiftUI, they've been a little more hands-off. And also very unopinionated, that the tools they give you are fairly flexible and you can sort of build whatever architecture you want. And so a lot of people, take their crack at figuring out what what the best architecture is going to be for them. And there's a whole bunch of different ones. There are trade-offs for every single one. This is one of
Right.
them. So let me explain a little bit about what it is, and maybe we'll get into some of the advantages and challenges, because it's been super interesting to work with. So the Composable Architecture is a library that provides a very opinionated way for how to structure your app. If you're familiar with Elm or Redux or some of the sort of functional reactive paradigms, and specifically unidirectional data flow, it is definitely sort of in that pantheon. The basic idea is that you have state. So you have some piece of state, and your whole app is represented as state. If you've been working in SwiftUI, this should be pretty familiar, because SwiftUI really emphasizes the idea that views are a function of state. So you have some state, and then the only thing you can do in the app is produce an action. So user pushes a button, that's an action. Network request or database request comes in, that's an action. And there's a piece of code called the reducer, and we can get into why it's called that if you want, but it's basically the signature of a reducer is it takes your existing state and some new action and produces new state. So user pushes the sign in button, the reducer looks at the current state, goes, okay, the user's not signed in, they push the sign in button, let's kick off a side effect to go do the login stuff. That will come back and produce a new action that will say the user logged in, and then we mutate the state to say user has now logged in. And all of this happens within the confines, the sort of sandbox of the reducer.
Okay. So here's kind of an example scenario where I've been doing a lot of combine. Is I will set up an object so that way there's like a pass-through subject for sign in, and look to see if the sign in pass-through subject has been sent. Something's been sent, right? Button's been pressed, whatever. And then it looks at your sign in state, and it takes those two publishers and uses literally combine, and then figures out, okay, it looks like this user is both signed out and they pressed the sign in button. Therefore, we should make a call to, to the Rust API call or whatever to authenticate. But this and that kind of sounds like what essentially is the reducer does. It's almost like I've been doing composable, probably not all the right pieces, but it sounds like it's essentially taking the power of combine and kind of like reducing every action into a series of states, and reducing those states further into whatever actions or new states need to take place. Is that,
yeah,
did I say that right?
For sure. And
okay,
the more I've learned about, like, I feel like I do some like mentoring and host some meetups, and I feel like a really common question that I get from newer iOS developers is, what architecture should I use? Or like, hey, MVVM, what does that mean? And I feel like the biggest thing that I've personally done in sort of leveling up my own understanding of iOS dev is to understand that they're all the same. Like that fundamentally all of these different architectures are about figuring out who's like which thing is responsible for which job, and keeping that all clear so you're not muddled about where things are going in your app. And then fundamentally something along the lines of what both of us just said about, you've got some state, you want to do something to that state. That's really what it all boils down to.
Yeah, that makes total sense. I mean, I think the big paradigm shift, I think the real paradigm shift over the last few years has been twofold. A, getting away from Objective-C and doing it that way, which, had made it easy in a lot of ways for programmers, but also made it difficult in a lot of ways, just kind of shifting the responsibility to the compiler essentially instead of runtime. And then with SwiftUI, we definitely see the big shift. I think the biggest benefit of SwiftUI is the view is now not just a series of commands and possibly storyboards, but rather like the view, you can kind of get a good idea of what you're looking at when you look at the code. It's all kind of that markup. And then so that way you can change, and then the state kind of defines how that view can be modified further. And that, I think, is one of the big benefits of SwiftUI, is that you have the separation of state and view. It's all in Swift code. And then I think like this composable architecture almost seems like the glue that kind of makes it easier to modify the state based on actions and such.
Yeah, for sure. And it really becomes clear just how strong that separation can be. We're always told, and we all tell each other, separate your, sort of content from presentation, right? This goes back to like HTML and CSS. Like you want to have what the thing is doing over here and kind of how it looks over here. But it
Yeah.
really became a clear distinction for us using the composable architecture because it's not just implied that you should model everything as state. It's very opinionated and very enforced that you will put everything in a struct called state, and then all your views are based on that. And there are some cool ways to sort of break that down into small pieces. But what we found is that we're using snapshot tests in our app in addition to logic
Okay.
tests. And
go ahead and explain. I know what
oh,
snapshot test is, but not a lot of people might.
absolutely. So both of them. So logic tests would be given some state, perform some actions, and then have a check that says, okay, did my state evolve in the right way? I received a user signed in action. Is my state now set to the user signed in state? And those typically run very fast. They're basically instant. They're just instantiating a piece of code or some struct or something, and then mutating it and then asserting on the result. A snapshot test is where you actually take a picture of a particular view or interface element, and then when you run it again later, it takes a new picture and compares it against the recorded picture. And Point Free has a snapshot testing library.
Right, I was about to say that Point Free has something. That
Facebook has one. There's a few floating around. We're using the Point Free one, and it's a different set of trade-offs from a logic test, because logic tests have really good signal to noise ratio. If you run a logic test and it fails, you go, oh, in this struct, the third element of the array, the color is set to blue instead of red. Well, color is a bad example because we're talking about snapshot tests. The user's logged in instead of logged out, right? It's a one little bool is changed and you can exactly see that. With a snapshot test, the failure of a snapshot test could be anything from your CPU architecture meant that the rendering of a gradient was slightly different, all the way up to the screen is blank in one of these and not in the other because I have a serious logic bug, and it could be anything in between. So they both have their place, but they have different trade-offs.
I want to hop back and talk. So your role right now is totally on this kids app, right? And how many are on the team?
It's 4 iOS developers, 4 like platform backend engineers, and then a bevy of managers and designers. So
the reason I want to ask is, what was it like? Sorry, I guess this is a green app, right? You had to implement this composable architecture on this brand new app. What was it like to get sign off from the other members of the team? And how was it like educating them on what this architecture was?
So I actually was not on the app from day one, but I was. So the app was started. The first developer on the app, who's no longer at the Times, but was there for many years, is, I'm going to try real hard to pronounce his name right, Krzysztof Zabłowski. It's Christoph who wrote Sorcery. He was the iOS lead for a while, and he started this project. And I think the pitch was mainly that this is a really good opportunity to try something new in the sort of skate to where the puck is going kind of way. That this really feels like it is something special and could potentially be a breath of fresh air, could solve many of the problems that we see around an app becoming too sort of entangled, where you have all your things routed through all the places. And that, if we're going to try something like that, this is a good time to try it. It seems like it has certain benefits that in the right hands, somebody could move very quickly with it. But also the testability story is so huge for the composable architecture. It basically, the way you write code in the composable architecture, it ends up being testable by default. You don't have to do anything. And I've really felt that as I came onto the team, that on other projects, I write some code and then I go, right, how am I going to test this? And I got to go and refigure everything out and inject stuff. And with the composable architecture, you build a feature and now it's testable. You can't not make it testable.
And that's one of the things is like I've seen a lot of people mention is like how difficult it is. Not how difficult it is to test SwiftUI. It's just they don't know how to do it. And like we've had Geo on and talked about his book, and one of the things is you want to test the logic behind SwiftUI or Combine or whatever is going on behind the scenes. And it sounds like this is one really good solution, is that it makes your SwiftUI code easily testable, transparently testable, as opposed to like having to figure out, like you said, reconfigure it to make it testable later.
Yeah, and to go back to what we were talking about with the separation of logic versus view test or snapshot tests, uh, when we do our snapshot tests, we actually use what's called an empty reducer, which is to say we explicitly say don't do any business logic. In the composable architecture, basically business logic goes in a reducer, and
Right, that makes
if you
sense.
new up your view and you pass in an empty reducer, you're saying not only do I not want any business logic, but there can't be any business logic. I can never accidentally do
Okay,
anything. I'm just testing that given some input state, it shows up correctly. And then
yeah,
separately, I can test
right,
the business logic.
right. That makes total sense. So I want to hop back and then talk a little bit about UI kit. So whether we like it or not, there's still UI
Mhm.
kit code out there. How does composable architecture fit into um, that paradigm, I guess?
Yeah. So the Kids app is all Swift UI, but we do have a couple of UI kit, representables here and there for things that mostly like sort of paging carousel kind of things. We just don't really have the control we need. So as far as that stuff goes,
Yeah.
it's pretty standard, pretty straightforward. It's really no different than it would be in any other Swift UI app. The composable architecture does support UI kit. It really is, again, skating where the puck is going. It's really set up to play nice with Swift UIs. Swift UI is very
Mhm.
comfortable with the idea of here's some state, make a view. UI
Yeah.
kit doesn't really speak that language as natively.
No, you have to kind of handhold
Yeah.
it and
Um,
like do all the work yourself.
but if you clone the composable architecture repo and look in the case studies, they have some really good case studies, a bunch of basically little toy apps, little one screen apps that do different things, and they have a whole section on UI kit. So if anybody's curious, they can clone it and see how that works. I think the gist from what I remember seeing from some of the point free videos is that you still have your store, which is the thing that holds onto the reducer and feeds actions into it and produces new state. You're just responsible for subscribing to updates to it and having a big function in your view that says, hey, I got new state, go update all the things. That's my basic
Yeah.
understanding. I know of people who've built large successful UI kit apps using the composable architecture because they weren't quite ready to switch over to SwiftUI, but I would definitely look at SwiftUI first if you're starting from scratch.
That makes sense. Um, have you thought about if you had like a bigger app, like you were going to go back on the New York Times uh, app team, and you wanted to introduce composable architecture into that app that's been around since whatever,
Mhm.
12 years? How would you introduce composable architecture in an already existing app with its own architecture setup?
Yeah, it's something we've talked about a little bit. The uh, there does seem to be a way to do that, sort of a migration path. The C in the composable architecture, composable, or I guess we haven't been referring to it as TCA, but everybody calls it TCA. So the C is composable, and that is a very important piece of the story with the composable architecture, which is the idea that you might have some you might call it a God object, like the state that is your entire app. It's got all the screens and
Mhm.
everything all in one big struct. But uh, the composable part means you can pull out just the state for one child screen and then build that whole child screen maybe as a separate Swift package. So it only knows about its own state, its own actions. You're in there doing your thing.
Okay.
And then there's a mechanism by which you can sort of reinsert anything you learned down in that child feature back up into the parent app. And that mechanism makes it pretty nice to like pull features out. A lot of the demos that they do in the point free videos is they will do some refactor on a child feature and get it totally building and even compiling and running in an example app without actually running the main app. So the main app might not even be compiling, but
Gotcha.
you can build the child one. So that's part of it, is that ability to trivially pull out any piece and say, this is now a division of parent-child, and you can pull this out and work on it. I think that helps a lot in thinking about this kind of thing. It more in terms of the nuts and bolts. There's a way, I don't remember exactly what it is because I haven't needed to do this, but there is a way to grab onto the sort of parent store of the composable architecture feature that you're using, and you can subscribe to a publisher of state. And that means that you can instantiate this view anywhere in a UI kit or whatever app, and then feed it some initial state, have it do its thing, and then kick back out some state at the end. So one of the things where this came up is we didn't end up going this route, but I think the login screen stuff got rebuilt recently in the news app, and one could theorize doing that with composable architecture. You say, hey, show the login screen, do whatever you got to do, social login, registration, subscriptions, all that stuff. I don't care about it. Just tell me when it's done. And if you wanted to build that screen in the composable architecture, you could totally do that. And the rest of the app doesn't really need to know. So it is definitely doable to build bits and pieces. I would say almost definitely easier to build sort of a leaf node rather than like, don't keep all your screens old procedural UI kit and update your core to TCA. I'm sure somebody's done it. I'm sure there's a way, but that direction doesn't really make much sense to me. I think you'd want to go the other way.
Yeah, where you have like a little pocket of the app that uses TCA, and then like as you build it, you introduce it more and more. What kind of like coordination do you have to do on your team with the 4 developers all using TCA? Like, is there any sort of discussions that you have or things you have to agree on?
Yeah, we're in communication a lot, especially when multiple people are on the same work stream. So we have a feature going on right now where basically 3 people are all working on different parts of it at the same time, just because that's how the sort of resource allocation ended up working. And it's definitely a mix. One nice thing about composable architecture on this question in particular is that everything is in a predictable place. You're never really having to invent like, hey, where am I going to put this? There are higher level versions of that question, but in terms of I'm building a screen, state goes here, actions go here, environment goes here. We haven't really talked about environment, but that's where you like talk to API services and things. And those are always the same. Those are always in the same place and they always look the same. And that means here's an example. I changed the analytics on a screen at the same time that somebody else was totally refactoring that screen and changing how it worked. And so when we got time to merge both of those, I realized, oh no, the action that I hung my analytics off of doesn't exist anymore. But no big sweat, because we merged the other person's branch first. And then in rebasing mine, I went, oh, I'm not using that action anymore. I'm using this other action. And it just slotted in. And it just because of that predictability of knowing that, oh, something's going to be happening, I know where to find that. It's an action in the reducer. And there's nowhere else it could possibly be. Makes it so much easier to sort of reason through, what different changes are, even if you're not super familiar with them. And that coupled with the testing story, where we've actually been able to write pretty good test coverage for especially the annoying business logic things where, this user has permission to see those 3 things, but not those 2 things, except on a Tuesday. And you gotta test all that. It's really nice to actually be able to write tests for that.
So you mentioned environment. What are some... We can start with that, but what are some other terminology that people should be familiar with if they're going to go with TCA? And we already did reducer, so we don't need to.
So there's the store, which I touched on briefly. So the store is sort of the object that holds everything and routes all the things to all the places. So the store holds onto your reducer, and when you send an action, it sends into the store, and then the store is the thing that produces new state, and that state is observed in the view. There's technically a thing called a view store, which is like sort of the viewy parts of a store. It was sort of introduced for pragmatic reasons. It's not really a very interesting distinction, and they may reunify the store and the view store at some point. The environment, the environment is kind of cool. It is a different way of doing dependency injection than I think a lot of people are used to. And Point Free have actually talked about this in the past.
Is this the whole world?
This is the world thing. Yeah. Have you talked about this on the show before?
Yeah, briefly, but yeah.
Yeah, it's episodes 16 and 18 of Point Free if you want to check it out. But so that if you're used to protocol-based dependency injection, this is where you say, I have my API client protocol, and here are all the endpoints it could have, the fetch user, fetch documents, whatever. And then you provide two implementations. You provide a live API client that reaches out with URL session, and you provide a fake URL API client that returns some data after some delay, maybe, and it's all fake data. And that's totally fine. That'll get you off the ground. But there are some issues there, mostly around symmetry. The idea that if you want to provide a fake API client, you have to answer the question to the compiler, what does every single one of these endpoints do? Because you have to make a type that conforms to a protocol, and so you have to provide some implementation. The point free version, and this is something that comes from before the composable architecture, but TCA definitely uses this as well, is the idea that your environment is a struct of closures. So it's like var get articles, and it's a closure that maybe takes nothing or takes a user ID and returns like a combined publisher of articles. Or in the async world, async returns some articles. And the nice thing about having it as a closure is that it's just a var on the struct, and you can swap it out. So you can instantiate the struct, maybe you have a default version, and then swap out this one thing that you need. So what they do, this is part of the exhaustive testing story of TCA, is that you make a single failing or unimplemented environment that has just like basically a fatal error. They have some nice utilities that make it not a fatal error. It's a nice test failure with a red thing in Xcode, and it shows you the right line and everything. But you have this unimplemented environment. You pass that into your store in a test, but then you say, hey, swap out, just like it's a var, you can just set a different value and say this one endpoint, set it to this test thing that returns a mock value. And what's nice about that is that if your code changes such that you accidentally call a new environment endpoint that you didn't realize you were calling, your test will catch it because it's exhaustive. It is only swapping out the methods that you actually need.
Nice. Sorry, you mentioned, yes, now I remember. You mentioned async and await. All right, so how does that fit into TCA if you're still using combine and publishers?
Sure, yeah. So TCA is currently heavily reliant on combine. The internals are very much intertwined with combine. But since the advent of async await, they have, I mean, the general wisdom on async await is like Apple wanted to make that. It wasn't ready, so they shipped combine. And that, combine hasn't really seen an update since it came out in iOS 13, I think. And that it was a stopgap, but the industry is, or the platform as a whole is likely to move toward async await. And TCA is moving along in that direction. I think the eventual goal is to drop the combined dependency. We're not quite there yet, but they've kind of been hinting at it in the Point Free videos. And so they did a series recently on async. It's a really good series. You should definitely watch it. They did not pay me to say this, but it goes into the history of like threads and queues and some of the ways to do concurrency. Like I got a much better understanding of async in general on iOS from that series. But they added some stuff to the composable architecture to deal with async. And I recently ported over a side project. It's a pretty big lift to port a whole project to it. So we haven't done it. We got to ship, so we haven't done it yet on the Kids app. But hopefully sometime in the fall or spring we'll be able to do that. But the basic idea is your environments get simplified, and they generally drop the dependency on combine. Because instead of returning, Point Free has this special publisher type called effect. It doesn't really do very much. It's mostly just a namespace to say, hey, here's a publisher that is doing TCA stuff. Just kind of a convenient hook to hang their extensions on. So in the old way of doing things with composable architecture, your environment endpoints would all return effects of whatever value they produce. In the new way, you can drop that. You can just say, hey, it async returns a thing, or throws, or whatever the normal function signature would be. And then when you handle those things in your reducer, there are some niceties and some utilities that let you run those async things and then have them interact with the rest of the TCA universe. So I just ported a side
Okay.
project over the weekend. It took, it's in the App Store. It's called Peep. It's a $1 voice reverser app if you want to learn how to talk backwards. And I ported it
Nice.
to the new async things in like half a day, maybe less. And actually maybe like 2 hours. And then I also ported, they're doing this big refactor to change how reducers are defined. It goes from a struct to a protocol, and there's all sorts of cool stuff that comes along with that. And I ported to that in like the second day of the weekend.
So let's talk a little bit about your apps in the App Store. Unless there was some other TCA thing you wanted to mention before we segue.
No, that's pretty much it. It's super interesting. You should check it out. It is non-trivial to adopt, but also really cool. I mean, look at the free video tour on the. They have like a 4-part video tour on the Composable Architecture repo that's free, and it makes a really compelling case that you should check it out.
And we'll put links to all that stuff in the show notes too. So no biggie. So yeah, I want to hear more about this Peep audio reverser thing.
Oh.
So how does this work exactly?
So I saw a video.
Wait, no. Why?
Why?
Let's ask that question.
So I watched a video on the Smarter Everyday YouTube channel a few years back, where he found this guy who trained himself to talk backwards. He just apparently he sat in front of his parents' Windows 95 computer, and they had this little voice recorder app, and you could just play something and then reverse it. And basically, as a party trick, he learned how to talk backwards. So and it's not like the spelling is backwards; it's like the sounds are backwards. So I happen to know my name backwards would be Grebna Ziavez. You can hear like the intonation goes backwards, and it's very weird. And so I saw this video, and I like party tricks, so I thought that'd be fun to learn. And I couldn't find an app that I liked that just did voice reversing without having a bunch of other bells and whistles. There were like voice modifiers, but it was a bunch of taps to reverse your voice. So I thought it'd be a fun sort of weekend project. It turned into more of a month-long project, to get the UI working and everything. But I had a prototype working in maybe a weekend. But yeah, it's a very simple app. It has a button, you push it, it records, and then you play, and it plays your voice backwards.
What kind of traction do you have on an app like that?
None traction.
No, it's a toy.
It's a toy. It basically, it and my other paid app, which is a juggling simulator, basically pay for my developer membership. And that's it. Because, I don't need to make money on these. I just would prefer to have that even out with the $100 a year it takes to put them in the App Store.
Yeah. And you get to learn TCA. So that's
I use these side projects as test beds to learn new stuff.
So here's what I want you to add is age simulator, because I've noticed if you like slow down, you have kids, so you know this, but if you slow down their voice, to me it's like eerie how much it sounds like an adult voice when you slow it down and change the pitch. Just throwing that out, that's a free idea that'll pay for maybe 2 years of development.
One of my favorite apps ever, which was definitely an inspiration for Peep, because I think by the time I was working on Peep, this one hadn't made this 32 to 64-bit cutoff, so it was just dead. But it was an app. I think it was called Voices. It was from Tap Tap Tap, and it was so delightful. It was a little gallery of different voice filters. You could tap on them, and then brought up this little microphone. It was definitely like delicious generation, which there weren't that many of on iOS, but it totally was.
Yeah.
Microphone would come up. It had curtains. It had theme music. Like you'd be sitting there browsing the home screen, and it was like smooth jazz while you were picking your filters. It was so good. And it had a voice reverser that I used before I wrote my own.
Anything else you want to talk about before we close out?
No, but go.
Did you buy a new phone?
Yeah, I got a new phone. I don't know if I'm going to leave always on display. I got a 14 Pro white 256.
Okay. I did not buy a new phone. I'm a little bit envious, but I'm also, I don't know. We'll see. Maybe later. But I bought new AirPods. They're not in yet. These are still, as of recording, I'm still using the AirPods Pro 1. But maybe next time I record, next episode, I'll have those in. Cool. Well, Zev, thank you so much for coming on. I really appreciate it.
Yeah, my pleasure. Thanks for having me.
Where can people find you online?
I'm at Zev Eisenberg on all the things, although I only really use Twitter.
People can find me on Twitter at LeoGDion. My company is Bright Digit. Please take some time to review on your podcast player. If it's iTunes, whatever, podcast app.
It's still iTunes on Windows.
Google. Yeah, I get it. For the 5 people out there, if you're still using iTunes on Windows 11 or Windows XP, put in a review. And if you're watching this on YouTube, or go ahead and like and subscribe. Thank you so much, Zev, for coming on. And I look forward to talking to everybody next time. Bye.